Yeah, I don't think I can overstate it. The analogy is very clear. For almost a century, um, linguists were constructing mathematical models of language, and you and I ordinarily we didn't see any benefit from that. It was all scientific progress, but one without really impacting society. And then in the last 20 years, let's just say from the time Google went public till now, they have been using computational methods, which is heavily statistics driven, without necessarily understanding the model of language. And they have made a ton of progress. And today, you and I can use Chat GPT to do ordinary things. And so therefore, there is social impact from that. In a similar way, these analytical methods that can extract sort of insights as well as guidance from our operational data um, are of a similar kind, the second kind. Now, a lot of times, the approaches people take are to create a specific equation, a specific algorithm, or a specific pipeline that is suitable for a failure mode, or sometimes even for an entire use case. And those approaches are hard to create in the first place because you have to have intimate understanding of physics and be able to do that with data. In my opinion, that path is really a dead end. We may make a little bit of progress, but we're going to get into that dead end. For the simple reason that when governing laws are known and we can create a physics based model, we will omit those things that do not allow us to create a clean model. And that, what we omit, is the real world. So, those approaches, which are either physics models or equation based, they have already done a lot of work. The gap that remains is not going to be filled by that approach. And in just the same way that autonomous driving went from individual use case, I have to turn a corner, I am driving through a rural road, etc. Every one of them was one block within the overall intelligence. Soon enough, it got replaced by deep learning.
Yeah.
And that is what is happening even for condition intelligence. And so, what Falconry has done is we have taken a deep learning approach to understand what conditions are happening. Those may be in the form of the statistical deviation from mean. They may be about a high limit or a low limit, which are easy things, but they could be about shapes, waveforms, distributions, frequencies, and naturally correlations across many of these such waveforms and shapes. And what we have found is that it is impossible to do all of this, what I just described, in a computationally efficient and an understandable way with conventional methods. And with deep learning, it is actually possible to do it in a computationally efficient way and an explainable way and in a generalized way, such that it can be benefiting many different scenarios. So, that I think innovation is essential. And unless we are able to use general methods, condition based actions will not make any impact on society.